Hello students. Since we have studied about the phenomena of interference and diffraction individually, so now it's the time to differentiate between the two phenomena, interference and diffraction, on the basis of what we have studied in both. So the very first point that is common in both is the both phenomena occur because of the superposition of waves, right? So interference as well as the diffraction both are the result of superposition of secondary waves, but there is a slight difference. In case of interference, those secondary waves start from two different wave fronts, like from first slit S1 and from the second slit S2, while in case of diffraction these both secondary waves, those are superposing, are starting from different parts of the same wavefront. So this is the first difference between interference and diffraction, that both occur because of the superposition of secondary waves. So interference it takes place because of superposition of secondary waves, but these waves are coming from different wavefronts, right? So secondary waves starting from two different wavefronts, although these wavefronts are originating from two coherent sources. So these two different wavefronts must be originating from two coherent sources. This is the condition of interference. Now in diffraction, again it takes place because of the superposition. It takes place because of superposition of secondary waves. Now these waves starts from different parts of a same wavefront. Secondary waves starting from different parts of the same wavefront. This is the difference between interference and diffraction. This is the first point. Now moving to the next point. So in case of interference, the fringe width we get, in case of interference the fringe width for bright as well as dark fringe is same, means all bright and dark fringes in case of interference are of equal width. So they have same fringe width, right, in case of interference, while in case of diffraction, a width of central bright fringe, in case of diffraction the width of central bright fringe is approximately twice the width of any secondary maxima. If we take any other secondary maxima, so the width of central fringe is twice to that width of any secondary maxima. Now there is a difference of intensity also in case of diffraction, while not in case of interference. So this is the next difference, that in case of interference all bright fringes are of same intensity, although in case of diffraction the intensity of bright fringes decreases as we move away from central bright fringe on either side, right? So as we move away from central bright fringe, the brightness decreases. So this is the third difference. Moving to the next one, next difference between interference and diffraction is, in case of interference, the region of dark fringe is completely dark, means perfectly dark, so it form a good contrast between bright and dark fringes, while in case of diffraction, the dark fringe are not perfectly dark and there is a poor contrast between bright and dark fringes. So in case of interference, the dark fringe region is perfectly dark, and that's why there is a good contrast between bright and dark fringes, while in case of diffraction, the dark fringe region is not perfectly dark. So there is a poor contrast in case of diffraction. So we get a good contrast in interference while a poor contrast in diffraction. The last difference between interference and diffraction is, in case of interference, at the angle lambda upon d, where d is the distance between the narrow slits placed there. So at an angle lambda upon d, we get a bright fringe. So if angle is equal to lambda upon d, where d is the separation between the two slits, so at this position, at this angle, we get a bright fringe in case of interference, while in case of diffraction, at an angle is equal to lambda upon a, where a is the width of that single slit we are using, width of single slit. So at the position or angle lambda upon a, we get dark fringe in case of diffraction. So in case of interference, at lambda upon d, d is the separation between the two slits, we get a bright fringe, while at angle lambda upon a, where a is the width of the single slit, we get a dark fringe. So these are the difference between interference and diffraction. First, they both occur because of the superposition, but in case of interference, the wavefronts are coming from two different starting points, or there are two different wavefronts from separate starting points. But here in case of diffraction, the points are the part of a same wavefront. In interference, the fringe width is same for bright and dark fringes, while in case of diffraction it is not same. Central bright fringe is quite large in size in comparison to the other fringes. In interference, the intensity remains same for all the bright fringes, while in diffraction it reduces as we move away from the center. In interference there is a good contrast, while in diffraction there is a poor contrast, and the value at lambda by d, we get a bright fringe in case of interference, and the position at lambda upon a, we get a dark fringe in case of diffraction. So these are the differences between interference and diffraction. Although these both are based on the phenomena of superposition, but there are certain differences. That's why these are two different phenomena. So that's all for the video. For further videos, stay tuned and keep studying. Thank you.